Good afternoon, pilot teachers, and good afternoon, students. Okay, thank you. Sit down. You might be looking at the subtopic on the monitor, and you might be wondering why we are going back to volcanicity. Basically, today in our lesson, we are going to look at a review or revision work on what we have already covered on the topic on volcanicity. But before we go on to looking at the revision work, of which it will consist mainly of reviewing or viewing a tape, and the tape is actually based on volcanoes in Papua New Guinea, and we are going to look at some information given from different qualified people on different volcanoes that we have in the country in terms of their eruptions and etc. And that is what we are going to look at when we look at the information from the monitor on the review on volcanicity. Before we go ahead to looking at our revision now on the topic on volcanicity, I'd like us to correct the activity or the exercise which I gave for homework. And before I do the correction on the exercise or the activity which I've given for homework, I'd like to recap very quickly on what we have covered so far on the topic on diastrophism. We mentioned that diastrophism is basically to do with folding and faulting of the Earth's crust under the influence of tectonic forces. Folding is mainly to do with the buckling of the Earth's crust. Faulting is to do with displacement of rocks along vertical fault lines or cracks. The surface of the Earth is actually changed, and it can also be changed under the topic on diastrophism, mainly on folding or faulting. The last lesson we looked at on the topic of faulting, we looked at the information on block faulting. Faulting can occur where there is only one fault line, or faulting can occur where there are multiple faults. And on block faulting, multiple fault line is evident. And along those multiple faults, then what happens is that some blocks are actually uplifted and others are depressed. Information from the monitor here gives us examples of some of the features which are created as a result of displacement in terms of uplifting or depressed blocks along fault line. One of those features that we have studied and we've looked at is that of hosts, which are simply uplifted areas between two parallel faults. We've also looked at the formation of grabens or rift valleys, and they are simply depressed areas between two parallel faults. We also looked at an example of block faulting in United States, and here it is mainly on the Great Basin, and the Great Basin is found in USA. It is this area here we're making reference to on block faulting. If we took that, only that area out and enlarged it, that is a sample of block faulting then in the Great Basin in United States. You can see there multiple faults. You can see the displacement of which some blocks are uplifted, others are depressed. We also looked at block faulting and a sample of that in Australia, mainly in South Australia. A cross-sectional view of that region of our case study in South Australia from point A to point B. And the cross-section from east to west, we will see saw us look at some examples of uplifted area, depressed area forming the Spencer Gulf and the St. Vincent Gulf, and the uplifted areas of the York Peninsula, and also the Mount Lofty ranges. That same cross-sectional diagram given, showing us again samples of block faulting on what we have covered in our last lesson. Okay, we have a photograph showing us an example of part of the uplifted block mountain system of the Flinders Range in the Shatter Belt of South Australia. So this is an example of the landform which is actually created as a result of diastrophism. Then to the homework activities. We are now ready to correct the activities. Your activities where you're supposed to find or use atlases, and from those atlases you were supposed to plot the following features, of which they are features which are formed as a result of faulting. Host and tilt blocks. We found out that the main difference between host and tilt blocks are, for the tilt blocks, they usually have only one pronounced scap, whereas for the host, there are 2 pronounced scap on that particular feature. There are many hosts and many tilt blocks around the world, but your task was basically to look at those 6 examples given, 3 of each, and to plot accurately on a blank world map where those features are actually located. Okay, you can check now your blank world maps. Actually, they should now be filled in with information on tilt blocks and hosts. Okay, we'll start off first with the tilt blocks. The 3 examples given there, the Deacon Plateau, the Brazilian Plateau, and the Arabian Plateau. Let's check the location and you can make corrections. Okay, looking at the Deacon Plateau, first of all, represented with the letter A, the Deacon Plateau should be in India. Okay, we check the area shaded in red and the arrow with the letter A pointing to the Deacon Plateau. We're following the information as lettered according to A to F on our monitor here. A to C will show the tilt blocks. D to F shows examples of hosts. Okay, we check in India, the Deacon Plateau. Let's look at the second one, which is the Arabian Plateau. Okay, look at Arabian Plateau, where Saudi Arabia is, and the country Yemen. Along that area, you should have the Arabian Plateau. The red dot with the letter B should represent that. Okay, the next example that you're supposed to also plot in will be that of the Brazilian Plateau. And for the Brazilian Plateau, this section here of South America, but in the country Brazil. So you check in South America, in the country Brazil, that's where the Brazilian Plateau should be plotted. Okay, that's for the examples of tilt blocks. Now we look at examples of hosts. The Korean host should be where the country Korea is. Okay, so here the letter D with the arrow pointing to show us where the Korean host should actually be plotted. Let's look at the Sinai host. This section here in Egypt. So Sinai host in Egypt. And if you look at the world map or your world map there, you will see a point which points out to where the Red Sea is. And that particular point or peninsula is where you're supposed to put the Sinai host. And finally, for the last one, the Black Forest host, it is actually located in Germany. If you've heard about the River Rhine that runs along those countries in Europe, Germany, Switzerland, and etc., the river runs in a rift, and that rift is known as the Rhine Rift. And on the right side of the Rhine Rift sits the Black Forest host, and on the left side is another host, and it is in the country France. And that's where we have the Vosges or the Vosges host. But this is in the other country. We're looking at the Black Forest host. It is in Germany. Okay, so if you look at the information from your map, you should be able to plot accurately according to what is shown also from our monitor then. Okay, we satisfied and happy with that, the correction of the homework? Okay, now we are ready to move on now with our work on, or the reviewing now of the work on volcanicity. And as I've mentioned at the beginning, the review is going to be based on looking at a tape taken on volcanoes in Papua New Guinea.
Mi si daw na re long road maiwak bikin ini pilay ng tindi Sa postmonen bay pairap bayumi go away Ating bayumi stop na dahil longi kason
The Barike band of Rabaul could not have predicted an eruption. The threat of it happening had been a talking point within the community and among the people whose business it is to know for over decades already. Hello and welcome. We've of course turned the page over those lovely images of Rabaul. Tonight, tens of thousands of people are in care centers in the Gazelle Peninsula after the volcanic eruptions, the English translation for Kaya Ivuvuai. The peak of the eruptions may be well and truly over. We could not get a volcanologist to say that. Until the Tavurvur and the Vulcan blew their tops off on September 19th, the population of Rabaul and surrounding villages had little time to evacuate, about 27 hours. That's from the time the big earthquake first shook Rabaul 3 a.m. on Sunday morning to the first eruption Monday morning at 6:15. MTV obtained first pictures of the eruption of Tavurvur. From Rabaul, our first documented report about the eruption from volcanologist Rod Stewart in a telephone conversation with John Higgins in our Port Moresby office.
The best comparison is actually the eruption of both Vulcan and Tavurvur in 1937. They both erupted at the same time like we're having at the moment, and the size of this eruption is very comparable to the size of the 1937 eruption.
From where you are, I know that the observatory is right on a hill there somewhere. Can you see Rabaul Harbour?
At the moment, I can only see about 20 metres away from the observatory. The whole town is covered in a thick blanket of grey ash that is being blown by the wind from both volcanoes towards us. So it is very difficult to actually see what is going on at the moment.
Do you have any reports about lava flow at this stage?
We don't have any reports of lava flows. During the early stages of the eruption, we observed it very carefully, and we did.
Everyone understands the damage volcanoes can do. What we also need to understand is when a volcano might erupt, what kind of damage they can do, and how to put a plan in place to prevent people from getting hurt.
Because Papua New Guinea is a developing country, more jobs, more people living and working today, it is important we know where to build homes safely. The Rabaul Volcano Observatory, with the assistance of the Australian Government's Volcano Service Support Project, is responsible for monitoring all of Papua New Guinea's dangerous volcanoes.
Blow up.
When Vulcan and Tavurvur erupted in 1994, it produced a frightening amount of ash, which blew across the harbour. The ash also covered Rabaul town, and 50,000 people were evacuated.
Morning turu, osemlo 6 o'clock, something 7 o'clock, mi play looking simugi kamantap. Mi play looking, mi tokim online blomir, kisimol gisala line by go past go north coast. Mi play ting wasem by north coast by safe. Na only go, na mi play lik line stop.
Naigapuo, ang marumihan ni Naragunan. Marumihan ni Naragunan ni gapila-bila uroboy siyan.
Tam balo si kirap na sampala. Olik-lik stop na giraw ni Karamapimol. Stop, long epot.
The ash from the volcano not only covered aircraft and the airport, it also covered houses and shops, and virtually all of the business sector was destroyed. After the 1994 eruptions, the residents of Rabaul realised the importance of building away from the constant danger. People began to rebuild at Kokopo because it was further away from the volcano and in a safer area. Local business is once again flourishing after having been relocated. Kokopo is still being developed with a lot of assistance coming from the Australian government's overseas aid agency. Today, Rabaul is a ghost town. The ashfall from the eruption had a devastating effect. The huge clouds of hot ash were carried by the wind over the township of Rabaul, where it continually fell, gradually building up and burying houses, vehicles, and eventually whole villages. The swimming pool that was once filled with the cheers of children is now filled with ash. Every Sunday, the locals crowded into this ground to support their team in action. Now, memories are all that remain. Yesterday's shouts of encouragement have now been replaced by a deafening silence.
Herman Patia is a senior volcanologist at the Rabaul Volcano Observatory. He is responsible for collecting and analyzing data, which is used to understand the volcano's activity.
When Taburbur erupts, it throws out pieces of rock, which land on the side of the volcano. One of my responsibilities is to look at rocks. I go out to Taburbur, climb up the flanks, and look for suitable samples. Break them up, and if I find that they are suitable, I bring them back to the observatory, pack them up, and send them to Australia for analysis.
The lava samples are sent to Canberra, where Rabaul volcanologists work with staff from the Australian Geological Survey Organisation and the Australian National University. These samples are cut into smaller pieces to produce thin sections. The thin sections are viewed under a microscope for their mineral content. They are also analysed in an X-ray machine for their chemical composition. The information obtained from these rocks assist RVO scientists to better understand how the lava forms underground and how the eruptions take place.
Because of Rabaul, we learned many lessons. After the 1994 eruptions, the Rabaul Volcano Observatory, with the assistance of the Australian government, set up a new monitoring system to record information from the 4 other dangerous volcanoes in Papua New Guinea, sending signals by HF radio back to Rabaul.
In 1997, a new monitoring technique was introduced at the Rabaul Volcano Observatory to monitor the activities of the other 4 dangerous volcanoes within Papua New Guinea. They are Ulamona, Kakar, Manam, and Lamington. What happens is that at the remote sites, there are setups where the data from those sites are transmitted to Rabaul. Now at Rabaul, the data is acquired and stored in this computer setup here. So after we receive it here, we use the offline computers to look at the data and analyze the trends of activity for those volcanoes. So if we wanted to know any activity of Ulamona, we would download the data for Ulamona from here onto those computers and look at the trends and see whether the activity is increasing or stays stable or reduced level of activity. From that, we can send out information to the relevant provincial authorities about the level of activity of those volcanoes. It's not the same as before, where we had to wait 1 or 2 months to receive seismic records, analyze them, and see what the level of activity was. This gives us more advantage in that we can monitor the activities of those 4 volcanoes on a real-time basis, which gives us time to provide any warning if there was any change in the activity, whether it goes up or goes down.
Lamington is located on the northeastern coast of Papua New Guinea, near Popondetta. For a long time, it had not been active, and many people living in the area did not know that Lamington was even a volcano. Then, on the 21st of January 1951, Lamington came to life. The eruption produced enormous black clouds of ash that rose high up into the atmosphere. Cascades of dangerous pyroclastic material swept down the sides of the volcano. The avalanches of gas and fragmental lava destroyed everything they came into contact with. Forests and houses were completely flattened. Vehicles were no match for the powerful forces produced by the volcano and were tossed around like toys. Nearly 3,000 lives were lost. Those who were lucky to survive suffered extensive burns that resulted from the glowing cloud of hot volcanic material. Since then, Lamington has been sleeping. Today, Lamington, like Rabaul, has two other specific dangers. Apart from the hot avalanches, ashfall, and if it rains, mud flows that can sweep down the mountain, travelling long distances. The ash gets washed down by the rain and becomes like a flowing river of mud, sweeping away trees and huge stones in their path.
For this reason, it is very unwise to build villages in valleys or near rivers that run down slopes near a volcano. Villagers should be careful not to build in the path of possible mud flows. Jonathan Kudwan is a senior technical officer at the Rabaul Volcano Observatory. His work involves assisting the scientists at Rabaul in studying and monitoring of the volcanoes. He is involved in looking at the seismic activity, ground deformation, and ash plumes that result from the volcano's activity. More recently, Jonathan played a major role in the production of hazard maps for the high-risk volcanic areas of Papua New Guinea.
Volcano hazard mapping is quite important in volcanology. It helps us with looking at areas that is vulnerable to risk. For instance, if we have a look at the mud flow areas, these are hazards that will take place mainly around the valleys that will have a lot of rundown at a time of heavy rain. We can also have a look at areas that can have pyroclastic flows as a result of big eruption around the volcano.
In Kaka, there's only 3 possible areas where there's mud flows. The red shows.
These hazard maps are very helpful in identifying which areas are safe or unsafe around the volcano. This can assist people who plan to build villages, businesses, or services.
Uluwun Volcano is situated near Kimby, on the northern coastline of West New Britain. Uluwun is often in eruption, and the Rabaul Observatory is concerned because there's a very remote possibility that the volcano could collapse into the nearby sea. Even though it may look like solid ground, the sides of a volcano can be quite weak, and sometimes during an eruption, large sections or even whole sides can collapse. This is a volcanic avalanche. It moves very fast and will smash and bury whole villages. If a volcanic avalanche falls into the sea, or a volcano makes a big earthquake, it can start a huge, fast-moving sea wave called a tsunami. A tsunami is what happened on the northeast coast at the Susano Lagoon in the Itape region. This is where a 10 to 15 metre high sea wave carried away whole villages and left practically nothing in its wake. It was the communities closest to the shoreline that suffered the greatest loss of lives and serious injury. If Uluwun was to collapse in this way, the devastation would affect the entire coastline of Kimby Bay. It could destroy local industry and commerce, storage facilities, government buildings and services, as well as many of the local communities. The village of Ulamona is based directly below Ulawun, where it operates a large timber milling industry. Because of the ever-present threat that Ulawun poses to the people living and working in this region, the Rabaul Volcano Observatory conducted a workshop which resulted in the production of an emergency management report on Ulawun and the Southwest Pacific region. This extensive report was presented to the people of Ulamona at an official function held in their community hall.
It's a result of the workshop where Mbin come up Lowalindi. Now after Lowalindi workshop, all money no been go stop nothing. They have been all work stop.
Prior to explaining the contents of this comprehensive report to the local community, the head of the Rabaul Volcano Observatory, Ima Itakarai, presented it to the Deputy Governor of West New Britain.
Let me hand him over this report. Igolo Honorable Deputy Governor Blayumilo here West New Britain.
The production of this report was made possible with the assistance of the Australian government through such agencies as AusAid and the Australian Geological Survey Organisation. The report outlines not only the dangers of cone collapses and tsunamis, but also explains emergency management and the reasons for the daily monitoring of volcanoes.
Summit clear early AM to 0900 local time.
Is a report igolo Ausguria all get a morning.
Roger.
Lo report him when something emi look him lo mountain for the past day.
Local time and onward.
This la walk where Martina you walk lo him lo here. Emi very important too where me plus use him lon monitoring my activity to Ulamona. This la all kind something too me play use him lo Narapla volcanoes play me lo other parts of Papua New Guinea. Thank you.
Gentlemen, some tags for you.
RVO staff are also working alongside international scientists. With the assistance of the Australian government, they are able to travel overseas to teach other scientists about what is happening in Papua New Guinea.
Locations of all the active volcanoes in Papua New Guinea, and they are Ulawun, Kakar, Manam, and Lamington.
They, in turn, gain information about new techniques which will better assist them in understanding the activity of volcanoes. In 1997, a scientific survey was carried out by scientists from the Rabaul Volcano Observatory and international scientific agencies from Australia, the United States, and Japan.
Stations are just in the Rabaul Bay area.
This survey, known as the Rabaul Earthquake Location and Caldera Structure Program, or RELAX, involved the installation of seismic recorders around the northeastern part of the Gazelle Peninsula. The data obtained from this survey resulted in the production of images which showed the possible location of magma bodies located beneath Rabaul Volcano.
It shows where the magma body is in the center of the caldera.
Well, this is a picture of man of Phyllis, but you can look him when I'm volcano stable when I'm up.
As long as
these survey results are also very valuable to RVO in helping to understand where earthquakes take place beneath Rabaul and how the magma, or lava, gets to the surface.
Easy way to understand him and where any yellow or red, any half or magma is that one.
As well as assisting the Rabaul Observatory staff in better understanding the activity of the Rabaul volcano, these colour-coded images are now used in awareness programs carried out in schools as well as villages throughout the Gazelle Peninsula.
Ground is solar pikamantap 2 meters. In the period of 1973 and 1993,
getting the information out into the community is a big part of the process of being prepared, concentrating on educating people to the risks, emergency plans and other matters.
Remember, a volcano is a powerful force that obeys no master and cannot be controlled. It can start off very, very small and gradually build up to be a big thing. Or it can start off big and dies off.
At the Rabaul Observatory, a plaque stands in memory of 2 volcanologists that were killed at Kaka. In 1979, as they camped on its rim, Kaka suddenly erupted, killing them both. Knowing the dangers, RVO staff put their lives on the line to prevent others being hurt or killed. They are required to do maintenance work at regular intervals on each of the volcanoes where monitoring equipment has been installed. The island of Kaka is located off the north coast of Papua New Guinea in Madang province. Simon Terhui is the senior technician at RVO, and part of his responsibility is to visit high-risk volcanoes like Kaka to ensure that the monitoring equipment there is in good working order. There are many people living and working around the lower slopes of Kaka, and these people could be vulnerable to any future volcanic activity. Bogia is situated northwest of Madang. Simon recently travelled to Bogia to service monitoring equipment installed here. The recording station at Bogia monitors the Manam volcano. Simon soon discovered that the equipment had stopped functioning because one of the solar panels had been stolen and needed replacing. People must realise the importance of this equipment and that the removal of any of this monitoring equipment places the lives of the people of Manam and also the lives of others at risk. Manam is situated northwest of Kaka and is a highly active volcano. An observatory was constructed up on the southern flank of this volcano in the 1950s and is continually maintained. Simon has travelled here to check monitoring equipment as part of the regular maintenance program. Directly under the observatory, in a specially constructed vault, a tilt meter has been installed. This tilt meter is used to show if there are any changes occurring in the slope of the surrounding surface of the volcano due to any major activity or ground shifts. The carefree and relaxed lifestyle of the people of Manam would make one think that they faced no danger. But the children are constantly made aware of the dangers of living under this potential threat.
It's where the magma will flow up. And it won't go to the atmosphere. It flows out and then follows the valleys down to the sea. And anything on its way is going to bend them up. And if you are along this path here, you know that you'll be bent.
In 1996, 13 people died when Manam erupted and pyroclastic flows swept down this valley and covered the village of Budua.
Pyroclastic flow yet. Odd plantasi bin come down, bin killing plenty old man Mary lo dislape.
Kan das is a harap turi sa come down.
Now speed.
Inarab game sans long.
No kate.
Pyroclastic flows travel down the sides of a volcano and into valleys very, very fast, faster than any person can run. Villages which are situated in valleys directly underneath the volcano are located in the danger zone. If there was to be an eruption, it could completely devastate these villages. It's important that the RVO have instruments in this area to monitor the volcano's activity, which in turn help look after the safety of these people. The dangers of an active volcano are obvious, but they aren't the only ones we need to worry about or consider. What about the volcanoes that are only sleeping? Barmas looks safe, fertile, and green, but it is only sleeping. It could erupt at any time in the future. Because of the possible dangers, people must not forget and must not build on these quiet volcanoes.
The Rabaul Volcano Observatory will do its best to understand the signs and to provide a warning as early as possible. But science is not perfect. It cannot tell us for sure and cannot prevent an eruption. It cannot save us if we remain ignorant to these risks, choose to ignore warnings, and refuse to follow good advice. So remember, learn about your volcano, look at the hazard map in your area, and develop an evacuation plan and practice it in case of an emergency. Above all, remember to build, live, and work in safe areas so that you can live happily without the constant threat of danger.
As the population grows and communities expand, Papua New Guinea will have to increasingly address how vulnerable people and investment are to the threat of hazards such as volcanoes, earthquakes, tsunamis, and landslides. The Rabaul Volcano Observatory will continue to have an ever-expanding role in advising on the safety of communities and on the risk attached to new development projects. In order to further reduce the threat, it will need to liaise even more closely with other agencies, as well as with those communities who are most vulnerable. The Rabaul Volcano Observatory is here to ensure a safer and more secure future.